Hello friends, in this video I'll be demonstrating how to use SAS Enterprise Miner. For this I'll be using the dataset provided in Kaggle Adult Census Income. The link for this dataset will be given in the video description. So first of all, I'll open SAS Enterprise Miner. Due to time constraints, I've already built the model, but I'll show you how to do it. So first of all, when you open SAS Enterprise Miner, go to File and click on New Project. A new project will be created. Go to this Diagrams tab and then right click and click on Create Diagram. Give the name of any diagram and you'll get a blank canvas like this. So the first thing that you have to do is you have to import a data file. For that, go to this sample tab and click on this file import and drag and drop it here. Now when you click on this file import, you will see properties related to it here. Now while importing a file, just click here and you'll see options for importing this file from either your computer or SAS servers. So if you have a file on your computer, just click on browse and select the file that you want to upload and click OK. Now, after you have imported this file, just right click on it to see the data in this file. Click on edit variables. So here you will see all type of the columns that this data has. The role of the columns are defined here. So you have to select a target variable among these different variables. I have selected this is income as a target variable because I'll be predicting what the income of a particular person is according to these input variables. Now to explore your data, you can add this control stat explore. Just go to explore and click on this stat explore and drag and drop it here. Now link this to file import and you just have to right click it, run it and view the result. After viewing the results, you'll see a chi-square plot of every attribute that you had, and this will show you the most significant variable that will influence the target variable. You have other important outcomes here as well. Now moving on, we'll add this data partitioning. Just click on from this sample tab, just drag this data partition here and create a link with Stat Explorer. So through this data partitioning, we will allocate the percentage of our input data to training, validation and test set. Just be sure that the sum of training, validation and test set is 100%. Now since we are running multiple models on this particular data set, we'll add a control point to it. This control point can be added from this utility tab. Just click on utility and drag and drop this control point and link them. Now for modeling, I'll be running decision tree and neural networks on it. So these models can be found in this model tab. Just click on any model and drag and drop it here to run modeling on it. I'll drag and drop decision trees and neural network and create links to them. Now after adding every one of these, just right click these and run them so that the data can be passed through each of these points. Now for running this decision tree, right click on this and click run. After running decision tree, you can see the results in this result tab. Now on this result tab, you can see fit statistics, the tree itself and the ranking and overlay of this cumulative lift, gain, response, leaf statistics, tree maps. So first we'll see the tree here. As you can see, it's pretty easy to understand. It's split on each variable at a particular node, and as we can see in each node, the amount of data that's predicted in the training set as well as validation set. So when the percentages are quite high, there are no further splits, and when the percentages are low, the data is again split according to another variable. Now in this output tab, we can see different results which can be used to interpret these models. We have the misclassification rate and the sum of squared errors. We also have the true positives and the false negatives here. Now moving on to the neural network. Right click on this neural network and click run, and then when it is complete, click on results to see the result of this neural network. You can see here we have the fit statistics, the cumulative lift gain for these, and when we see the output here, we have the levels in this neural network. We have the misclassification rate as well as the sum of squared error and average and root mean square error. We can also see the true positives and the false negatives here. Now the accuracies of a neural network can be increased by optimizing the neural networks. In this case, when we click on this neural network and click this optimization tab, we can see that the maximum iterations it does is 10. Now I have created another neural network. In this we have the same data set, but in this case we have the maximum iteration set to 200. So when we run this neural network, it will have a better results than this particular neural networks, and we can compare the results of these neural networks in this model comparison, which we can get from this access tab. Just click on this model comparison and drag and drop it here and create the links. So now when we right click on this and run and click on results, we can see that the difference between tree neural and neural with 200 iterations, which is this neural 2, are given below. The average squared errors, which is the lowest for this neural net with 200 iterations, the average misclassification rates, and many such things can be compared in this tab. Now the 4 concepts that I have learned from the class and that I applied in this video are that decision trees work very well in dealing with discrete values, and it is very easy to understand upon seeing a decision tree what it does. Anyone can predict the outcome of any data looking at these decision trees. Now for the second concept, the data provided here was non-linear. In general, neural nets are supposed to work better for non-linear datasets. As you have seen in this case, the results for neural nets were better than the decision trees. Now the third concept was that neural nets perform better with increasing data or performing more iterations of the data. As we have seen, with 200 iterations of the same data, the neural net was able to perform better. Now for the last concept, as we can see, having all these different data models, we can use parameters like true positives and false negatives to calculate the risk involved with predicting using these models. So we can use these parameters applied to different models and see which model is the best in terms of cost associated with the result of these particular data models. That's it for this video. Thank you for watching.